All right, guys, here's your lesson on physical and chemical changes. Um, Changes in matter can be divided into two types, physical and chemical. I'm going to move through this quick because bandwidth at my house is at a premium. You can pause it, slow down whenever you want. So, a physical change, no new substances can be formed. You can change its state, size, shape, but it's still the same substance. If you cut up a piece of paper, it's still paper. If you melt a block of ice, it's still water. Water is ice. They're not, I know we have different names, but it's still H2O molecules. If you dissolve sugar in water, you still have sugar, you still have water. Salt water, you still have salt, you still have water. That's dissolving. So if you have something dissolving in a solution, it's still just a physical change. Here's a couple examples right here. You boil water, it's changing state, but it's still water. When you heat up a piece of metal, it expands, it can glow, but it's still the same metal. When you break a test tube, you're not going to get your test tube back, but it's still glass, just bits of glass. Most, but not all physical changes can be easily reversed. Which of the previous examples is not? Well, it depends on what you mean by reversed. If you heat up the metal, just let it cool and it's going to go back to regular. If you break the test tube, you're not getting your test tube back. But you can clearly see that it's still glass. The one that's not even on here that I'm going to talk about is the dissolving. How do you get your salt back if you dissolve salt in water or whatever that substance is right there? Let's assume it is salt. You can get your salt back by boiling out the water. If you boil water, the salt will be left in the bottom. Not in the same granulars that it was before, but you'll see a white film that is the salt. Anyway, dissolving is also a physical change, as I said. When you dissolve salt in water, the salt particles spread out, but they're still in there. They're just being hidden by the water molecules. And like I said, you can evaporate to recollect your salt. Now on to chemical changes. In chemical changes, you get new substances. It's not water anymore. It's not H2O. All right, the original substances changed into one or more different substances that have different properties. Examples are burning, cooking, rusting. Just some examples. The main clues we're going to use in this course to hunt for chemical changes are as follows. If you get a new color that wasn't there before, it is usually a chemical change. Now, these are clues. This is evidence. It's not, but a color change is a big one. For example, this one right here, you're seeing a color change. What that was two clear colorless liquids added together to get that yellow. If you get heat or light given off or absorbed, so it's not the case of heating up metal. And heating up metal, you are adding the heat to that situation. But when you burn something like magnesium that burns very hot and bright, and you're not supposed to look at it, once you get it ignited, it produces its own heat. So a campfire even. Anything that you burn or explode, heat and light is being given off, and there's a chemical reaction happening there. If you get bubbles to form of a new gas, okay, so I'm not talking about boiling water here. There's this guy right here. If you put a piece of copper into silver nitrate, and that's not what's happening there, but then you're going to get bubbles forming on the copper as a gas is given off. A solid material forms in a liquid, and that has a special word. It is called a precipitate. And then I'm going to direct your attention back down to this yellow one here. I can't remember. I think that it's It's definitely potassium iodide and maybe sodium nitrate or something like that. It's two clear, colorless liquids you add together. And in the end, you get this powder. I know that doesn't look like a powder, but it is. It's a powder that's suspended in that liquid. And if you leave it overnight, it all will settle at the bottom into this solid powder that in those two colorless liquids. It's actually a pretty cool reaction if you have the time to look it up. And then finally, the change is difficult to reverse. If I burn up this magnesium, none of those substances that I started with, I can't get them back. If a nail rusts, like you can scrape the rust off and you still will have iron underneath, but that rust is very difficult to change back into steel or iron. So that's your quick little lesson on chemical changes versus physical changes. There's some work I want you guys to do in the book and submit your work just like you've been doing. It's been looking great so far. So let's go here. Let's have a look at what your work's going to be like tomorrow. I have the section posted there. I want you to do on page 186, number 1 to 7, which I think is all of them. I used to have a worksheet to go with this that just essentially lists 20 or 30 examples of different things, and you have to say whether they're a physical or chemical change and why. But this does cover that. It talks about, especially in number 7 here, it says, think about the following situations and describe one chemical change that's occurring and provide evidence of the chemical change. So for evidence, I'm just thinking about those things that were on that last slide. Are any of those things happening? If they are, then you put them in as your evidence that a chemical reaction is taking place. Anyways, that's all you have to do for the first couple of days this week. And then I have a lesson I'm going to do with you on elements, and then a Google Docs assignment for you to fill out on elements. And that's going to be it for now, guys. I told you that bandwidth was at a premium here, so I better get off. I was hoping to keep this under 10 minutes, so hopefully I did. That's all for now. Email me if you have any questions.